Streaker here. Welcome back to Montville Math, and today we'll be exploring factoring, one of the most important concepts you need to know for algebra. Okay, so all factoring does is it helps you turn a polynomial into easy equations from which we can derive x. Okay, so x squared plus 8x plus 16 is 0. So there's two rules when it comes to factoring that you must never forget, because they're the two rules that you'll really need. Okay, so we're trying to find the constants that will help us derive x. Okay, so this is x. This is also x. A quadratic will create two constants. So the rule is let's call the constants they're not the constants aren't x yet, but they're almost x. So let's just call the constants c. Okay, so the first constant plus the second constant must equal the middle number. The first constant, okay, c1 plus c2 equals 8. So and then the first constant times the second constant. So the first constant, first constant times the second constant will get you the second number, which is the constant in the quadratic. Okay, so basically we're trying to find two constants, x plus c1, x plus c2. c1 and c2 can be negative, so it can be x minus something also. Okay, so to get these constants, we're going to use the fact that c1 plus c2 equals the middle number, which is the constant right next to the variable that has x to the 1, and the first constant times the second constant will be the actual constant of the quadratic. Okay, so now that we have that clarified, let us continue, shall we? Okay, so to find c1 and c2, we're going to use what the problem has given us, and the problem so nicely has given us c1 plus c2 and c1 times c2. Okay, now the easiest way to do this is not guess and check, but instead list all the factors, meaning all the possibilities of c1 times c2, that so from there we can deduce all the possibilities that fit this c1 times c2 constraint before we move on to this constraint. Okay, so 16 can be okay, so the factors can also be negative. That we have to find the factors of 16 because the factors are the possibilities of c1 and c2. Okay, so the factors of 16 can be negative, but I'm 100% sure that they're not going to be negative because all the numbers are positive in this equation, like positive x squared, positive 8x, and positive 16. So we're just going to list all the positive factors because that's all we're going to need. Okay, so 16, it turns into 2 and 8. So 2 plus 8 is not 8. Okay, so another two factors of 16 are also 4 and 4. 4 times 4 is 16. 4 plus 4 is 8, so we can safely say x plus 4 and x plus 4. The reason we're doing this is because we can now use the zero product property, so we can say x plus 4 equals 0, x plus 4 equals 0. You might be saying, but like they're the same equation, why are you writing it twice? It's a habit that's good to have, even with perfect squares. This is a perfect square trinomial, but everything else, and like almost all quadratics that you're going to encounter won't be perfect squares, so you're going to have to write two equations because these two are almost always not identical. Just as a beginner example, we're using them here as identical. Okay. So x plus 4 equals 0. What the zero product property says is like whenever you have something x plus 4 times x plus 4 equals 0, then each of the individual things is 0 also. So x plus 4 is 0, x plus 4 is 0, x equals negative 4, and we shall move on. Okay. X squared minus 5x plus 6. Okay, so let's put down our form, our standard form for factoring, and let's move on. So now, before we bang out all the factors of 6, which you might be going, ooh, I know, I admit it's easy, but there's a catch. This is a negative 5. And so we need to determine, okay, to get a positive number, you can either multiply 2 positives or 2 negatives. Okay. And so C1 plus C2, you get negative 5. Include the negative, okay, or else you'll get it wrong. So if you add the numbers, you'll get a negative, and if you multiply the numbers, you'll get a positive, right? So the two numbers both have to be negatives, because a negative minus, because a negative plus a negative is a negative, and a negative times a negative is a positive. So that's the only way that we'll be able to factor the quadratic. So we have to list 2 negatives. So there has to be negative something and negative something for C1 and C2. Okay. So, what do you multiply to get 6? Minus 6 and minus 1. However, minus 6 minus 1 is minus, if you add it, it's minus 7. So that will not fit for first constraint. But instead, if you do minus 2 and minus 3, negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So we could just go ahead and write negative 2 and negative 3 equals 0. And using our zero product property, x minus 2 equals 0. X minus 3 equals 0. X equals 2. X equals 3. Okay, if you're confused about the zero product property still, basically if two things multiplied by each other equals 0, then each of them individually. So like x minus 2 times x minus 3 is 0, then x minus 2 is 0, and x minus 3 is 0. So you get the point? Good. Now we have 2 solutions, which is the most common case for all quadratics. So we just circle them, or you'll see them most commonly referred to as x equals, in this case, 2, 3. Meaning x is 2 and 3. Okay. Our regular way of solving quadratics will not work here because the coefficient is 3. How do we solve this? Okay, let's not lose our heads here. It's not that hard. We have a little higher of a difficulty here because, okay, so Now, not only we have a constant after the term with the x, we have a coefficient for the x. So now it's going to be a little harder. Okay, so let's see the factors of 3x squared. So, 3 comma 1. A rule I have to mention for all quadratics, the coefficient has to be positive. The coefficient for the linear term, like the main coefficient, the only coefficient actually for your zero product property, basically these things, okay? The coefficient of both of them has to be positive. Okay, so since that makes our life slightly easier, because there's only one possibility, a 3 and a 1, because 3 times 1 is 3 and there are no other factors, so you could safely say 3 and a 1. Okay. Oh, and you could just delete the 1 and say nothing. Okay, so we could safely write x here. Remember, the coefficient for quadratic, coefficients of these terms over here cannot be negative, so keep that in mind whenever you're doing a problem where the coefficient of x squared is not 1. Okay, so 3x and x. What do we do now? Okay, so let's just see what the signs will be. Okay, so if we're multiplying and we're getting a 5, if we're multiplying and we're getting a positive, but we're adding and we're getting a negative, it means that it has to be like this problem in which the two numbers both have to be negative, since negative is positive. And yeah, I already explained that. Okay, so yeah, we can safely put minus signs here. Okay, now the actual number. So let's just guess and check. 5 is 5 can be either 1 or 5 only has one possibility. Actually, two possibilities. You could either be 1 or 5, or 3x minus 5, 3x minus 5, x minus 1. Okay, so what you do here is 3x minus 5, 3x minus 1, x minus 5. So 3x times 5 is 15x minus x is, that won't work. Okay, so that there's only one other possibility. So 3x minus 5, x minus 1. So minus 3x minus 5x is negative 8x. And so I'm happy that we have finally found our binomials that multiply. Okay. So now we can just use our zero product property, x minus 1 equals 0. That's easy, x equals 1. 3x minus 5 equals 0, slightly harder but still easy. 3x equals 5 and x equals 5/3. Hope you can see that. X is 5/3 because this equals 0 and this equals 0. Okay, this one seems like a toughie. It's not even quadratic. I thought we were factoring quadratics here, but okay. It's a cubic, meaning that it has an x to the 3 or x cubed term. Okay, so now there are interesting things we can do here. Okay. Wait. There isn't a constant. Where did the constant go? Oh. 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 You don't notice it yet? I'll show you. So basically, there's just one key step to do. Whenever you have a cubic and you want to turn it into a quadratic, make sure there's no constant. If there's no constant, then you could just factor an x. What do I mean? I mean you could just directly take an x away. How? Because if you divide x cubed by x, you get x squared, right? If you divide 27x squared by x, you get 27x. And if you divide 72x by x, you get 72. Okay. So we just found a trick here. Whenever we have a cubic and there's no constant, we could just factor an x and turn it into a quadratic, like as we did here. You see? Okay, that's just one part of the way down. We still have a couple to go. Let's do what we have been doing the whole time. So something times something equals this, and something plus something equals that. So, okay, I see a big number over here, so I'm not going to go around listing every possibility of 72, because that'll take forever. And since we know we have we have all positives, the results are going to be positive down here. Okay. Good. So let's try using bigger numbers since x plus y is 27. Okay, so 72 and 1, that's 73. 36 and 2, that's 38. And 24 and 3 is 27. That was easy, right? Just, I suppose, use your common sense and life gets easy. Okay, so x plus 24, x plus 3. Now we could use zero product property. So we have 3 factors here, not 2. Since it's a cubic, we have 3 factors. Although our first factor is really easy, you can just factor an x. So as the zero product property says, x equals 0. Thank you, they gave us the answer for one of the terms, x equals 0. Then x plus 24 equals 0. So x equals negative 24. Because x plus 24 equals 0. Subtract 24 on both sides and you get x equals negative 24. X plus 3 equals 0. So x equals negative 3. Now that we finished those factoring problems, I hope you learned how to factor. Like, subscribe, and comment to Montville Math. Have a good day.